Hello and welcome to this Building Domain session as part of the buildingSMART International Summit, Singapore 2025. Thank you for joining. My name is Laura and I will be your moderator today. Today's session is titled Introduction and Proposal Update. The speakers for this session are shown on the screen. This session is scheduled to last 19 minutes, including time for questions at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to our speakers, I would like to remind you that this is a hybrid event. For online attendees, your microphone will remain muted for the duration of this session. If you wish to make a comment or ask a question, please use the chat box in the control panel. For the attendee here in the room, please keep the background noise to a minimum. And if you wish to make a comment or ask a question, please raise your hand and use a microphone. I would also like to bring to your attention that buildingSMART is committing to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, and standards that develop do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct. Now I would like to hand over to Rob.
Hello, everybody. Yes, thank you, Laura. Yes, so this is can you hear me all? Yeah, okay. So this is the agenda of today. So first, I'm going to introduce you a little bit to the building domain. Then we are having the fire safety activity, which is presented by Yoon and Peter. And then we switch to online. Sam Norwich, he is in the UK and he's doing a presentation together with about IoT. Well, who is new to buildingSMART? No one. No one, really? Okay, so you know all about domains then already. So my presentation will be very short. Normally I try to introduce it a little bit. We have several domains. And, well, of course, you know it already. They are all focused on specific areas of our construction eco environment. The building domain, we are supporting, as you can see, digital standards and solutions for buildings. So more vertical build than horizontal, because then you need to go to the infrastructure room or the domain, for instance. And if you want to know more what we are doing, I suggest you go to the building domain charter. It's on the website. And I think everybody will receive these slides afterwards, so you can click through it. We have a nice roadmap as well, which you can download as well. You can see it for yourself. And our steering committee is really an international environment, or really an international committee. So we have people from Hong Kong, UK, Ireland, Canada, from the Benelux, from America, HOK is there. So I think it's well balanced and very well organized. We meet every month. Every month we have a project steering committee as well. And in those sessions, projects like we are going to present today are seeing the sunlight and are moved further towards these kind of sessions where we explain what we are doing and how we can facilitate your day-to-day business. The key objectives are, well, we are aiming for, as we call it, asset lifecycle information management. So we want to have the total lifecycle of the assets covered, not only in conceptual phase, design, but as well construction and, of course, demolishing, or as we call it today, harvesting. And we are working towards a digital project management environment. We work very organized, so we use a tool like Monday, where we have all projects and activities, and all the news that are coming from the building domain are published on the buildingSMART International website, as you can see on the right. So there's a little header, it's called Domain News. I suggest that you go there, take a look, and you see there as well what the status is of the projects that we are presenting here today. So enough for me, because you all know buildingSMART. So I had so much in mind, but okay. So I leave it now to Yoon and Peter. Yes?
Thanks, Rob. Can you all hear me okay? Yep, great. So today I'm going to present the fire safety activity, the next phases that we're entering, and I'm presenting with Yoon Ko from National Research Council of Canada as well. She'll be speaking during the presentation. And also the project leaders or work plan initiators are Asim Siddiqui and Peter Lawrence from University of Greenwich. Between the four of us, really, we handle the management of the project and share those responsibilities. So we're going to be focusing today on fire modeling and fire risk assessment together as we move forward and ultimately develop IDS files and expand the IFC BSDD to define those data points. And today we're going to cover the key motivations behind the project, why we're here, what the big push is to enrich the IFC world with lots of fire safety related data definitions, and also how fire safety engineering fits and enhances within the OpenBIM digital workflow. Then we're going to cover key aspects of fire safety, the general scope of the project, and focusing on the two tracks, specifically fire and smoke modeling, and also the fire risk assessment. And we'll be explaining what both of those things mean exactly on the way through. And also some notes about project delivery, how we are going to define, deliver, and report on the progress through this project. A little bit about the current status and the sponsors of the project. So that's what we're going to go through today. Yoon will be focusing on the fire risk assessment aspects. First of all, the key motivations, why we as a group collectively are working on this. You can see from the map up there, it's just an illustration that there are between 100,000 and 150,000 deaths per year in the world of fire still. It's a pretty high number. It's particularly obvious in the red areas where there's a high rate of mortality from fire, usually because of poor implementation of fire safety regulations, but it's surprising in other countries where you would think it was much lower. So it's still an issue, it's a big issue, and we can at least help that process by making sure designers have good data to design with. Fire safety depends on understanding the core physics of what goes on with fire. So you see in the video there, one of the experiments that we do at the university, which looks at the smoldering fires in lofts or attic spaces, which can quite unpredictably suddenly just explode in a ball of flame, given the right trigger conditions. So if we're going to model those processes, we really need to understand what's going on with modeling based on high quality data. We can only do that by defining exactly how that data schema looks. In the video, you can see one of the aspects of what we model is where you can put the fire out, but then 3, 4, 5 minutes later, it can all start again. So we can only understand those phenomena by having really well-defined models. Additional motivations are, well, the Grenfell inquiry highlighted what happens when all of this goes wrong, when a combination of building design fails due to not understanding the way that things plug together, and also management is failing as well. And also based on those range of disasters, the International Fire Safety Standards Coalition called for a decade of action to upgrade global standards for fire safety worldwide. And lastly, in the modern world, climate change is really affecting many aspects of how we design now. It's important to know when the fire's outside the building, that the materials we use and define carefully will ultimately dictate whether or not it stays in place safely or whether it unfortunately catches fire and goes down. So again, only by having high quality data can we hope to design properly that way. Before we dive right in, a couple of key definitions here. So fire safety design is the process of designing buildings safe from the impact of fire while ensuring they meet the safety objectives. It's a general design process. We're trying to keep the people safe in the building. And fire safety engineering is a much deeper dive than just core design. So fire safety engineering looks at the science and the modeling of what goes inside the building, and it's fire safety engineering which particularly requires those rich data sets. Key objectives of fire safety engineering are achieving life safety, and we do that by modeling the evacuation of buildings to minimize harm to occupants. Fire prevention, so we're reducing the chances of fires occurring. Fire protection, so looking at the way that sprinklers activate and they interact with the fire, and also passive fire resistant materials and fire safety measures as well. Property protection, so limiting the fire damage to the buildings, and also let's not forget that after the event we want to return to business as quickly as possible, and also try to ensure some level of environmental protection. So we want to avoid too many toxic products going up into the atmosphere, so understanding the data definitions inside the materials in that respect is very important. Fire safety exists within a very multidisciplinary world of BIM, you know, from all the different rooms and the different jobs and lives of the people that are here. There's many different disciplines involved. Within general architectural design of buildings, we have structural engineering, environmental, energy and HVAC engineering, facilities management, and furniture and products. Most of those aspects are reasonably well defined in the world of IFC with a buildingSMART data definition. Occupant movements is a project phase we've just finished and submitted for review by the committee. So that's in submission stage at the moment with all the occupant movement data, which should shortly hopefully be added to the data dictionary. But within everything there, fire safety design and engineering touches on all of those disciplines, and it's really those aspects which we intend to lift up and connect together, because structural engineering is key within the fire safety design domain, environmental and energy performance as well. So all of those aspects lie within the fire safety domain as well. There are some key approaches to fire safety design based on two particular ways of doing things. Most of the buildings take this prescriptive based approach. You literally have a set of rules and guidelines, specific travel distances to doorways, specific door widths, standard materials. That's prescriptive based design, usually applied to houses, small, medium-sized commercial buildings. But then we have performance-based design, usually based for medium to large-scale projects, and it's the performance-based design where you look in deep at the different aspects of what goes on. Occupant movement analysis. So in the fire safety engineering performance-based design, most people will be simulating or modeling the evacuation movement from the building to generate a number which we call RSET, the required safe egress time. The fire and smoke modeling generates a number called ASET, the available safe egress time. And quite simply, we just want to make sure that spaces become unsafe and untenable after people can get out of the building. So we want to make sure that the available safe egress time is a higher number than the required safe egress time. And that's at the very base level what performance-based design is about. Complementary to all that is the fire risk assessment process, where you start to look at multiple scenarios in the building, possibly fires generating in different rooms with different levels of probability and different consequential loss. That's the fire risk assessment, which Yoon will be covering in some more depth in a few minutes. So that's a nice schematic picture of the way that the design processes work in the fire safety world. You have your rules-based guidelines and then your in-depth engineering analyses. So the occupant movement analysis data definitions are in submission at the moment, and we're covering the fire and smoke modeling and the risk assessment today. A few notes about, something's gone with the fonts there. Core data definitions in fire safety engineering. There's 5 areas. Structural fire engineering and fire protection systems are both reasonably well catered for already in the world of IFC definitions. But fire dynamics, evacuation analysis in the form of occupant movement, and fire risk assessment are areas which are being enhanced at the moment. So the occupant movement analysis is under review. Fire and smoke modeling, we are in the process of starting that phase for gathering all the data, and fire risk assessment as well. It's the fire and smoke modeling, the fire risk assessment we're focusing on going forward. So the next part of the picture, or if you like the jigsaw puzzle, is focusing on the data blocks that we'll be defining on the way through. At the core is fire data. So when we model a fire, we're going to look at the source, the point at which it starts, the size of the fire, how fast it grows, how that feeds into and generates a smoke volume into a room, the way the sprinklers might interact with it, the materials that it then feeds off, the fuel, and then also the space volumes and the way the fire interacts with the spaces. Complementary to that is the fire dynamics. So when we know the size and the growth of the fire, we then start to look at the fire and smoke movement and the transport and the way the gases move, the way the smoke barriers stop the fire and smoke movement, smoke extraction fans, structural analysis, and the tenability of spaces. And that's where we look at the modeling of when the toxic products build up in spaces and they become too hot. And the other aspect is the risk analysis. So then you start to look at multiple scenarios, sources of fires, the probabilities of those events occurring, and also possible costs, consequential loss, and consequential loss of life, and also the occupant risks going forward. So there's kind of 3 strands of data that we're collecting, and the fire data is the one in the middle shared by both aspects. We're generating 2 IDS files, one for fire and smoke modeling, and the one for fire risk assessment. So fire and smoke modeling, there are 2 aspects, 2 ways that we model fire and smoke. The first one, which is relatively simple, is called a zone model. And on the left-hand side chart, you'll see the movement over time, the growth over time of the fire, and on the vertical scale, the temperature. So in the zone model, we will model the fire plume. It develops, it grows. You get to a point of temperature in the room where the surfaces spontaneously ignite as the radiant heat flux builds and builds and builds. It burns fast and heavy for some time during flashover, and then it decays afterwards. And ultimately, we modeled that as 2 layers. We have a hot upper layer shown on the right diagram, and the fire plume and the lower layer. And we modeled that development over time in the zone model. And that's relatively quick to simulate because we model 2 blocks of things going on. The smoke zone as it develops and gets bigger and bigger and gets deeper in the space. And they're often used in the fire risk assessment processes. The more complex approach is using computational fluid dynamics to simulate the propagation of hot gases and fire through space. You see here an example of a Rhode Island nightclub post-analysis investigation, seeing the way the fire spread through the spaces and the way that all of the complex physical interactions happen in those cubes of analysis in CFD, ultimately getting to the point at which that space is unsafe to be in. And then the unfortunate backdrop of that is the Northern Macedonia nightclub disaster just a few days ago, again, demonstrating how dangerous nightclub fires can be. So now I'm going to hand over to Yoon to cover fire risk assessment.
Thanks, Pete. Yeah, so I'll talk about the fire risk assessment, and let me just briefly introduce myself. My name is Yoon Ko. Fire protection engineer, working as a senior research officer at National Research Council Canada. So many fire protection engineers, they have a background in mechanical engineering or civil engineering. My background, my undergrad, I studied architecture, and I started my career working with the architects, providing assistance in designing large assemblies like stadiums. So what it means is I learned the importance of life safety in designing buildings. So coming to the fire safety area, the one thing I learned is fire safety is such interdisciplinary and highly engineering field. It is. So, and like many other discipline areas, it has implication on through the whole life cycle of a building. So what this means is fire risk is, as I wrote here, fire risks are continually present and ever changing throughout the design, construction, and operation. So what this means is each phase we need to do this, the risk assessment process. The process has a 4-step in simple way. So we first identify hazard and figuring out the scenario. Then think about the likelihood, the frequency, and give a best estimates. What will be the consequence of it? Then we come up with the potential mitigation solution and figuring out which one will be the best. So what this means is the life cycles of the building, we need to repeat this process at the design stage, and then construction stage, and the operation, and even at the end of the use. So you can guess that how important it is now maintaining all this relevant data relevant to the risk assessment. So now you can realize that the information management platform is such important aspects in doing the risk analysis. So luckily we have a BEAM platform, and I search up some report. I think it's McGraw-Hill reports, the survey report, and in the report they mentioned that one of the emerging benefits of using the BEAM is safety planning and risk estimations, etc. So it's good. It's not just all about the productivity, but also the safety aspect is also included. So talking about the whole life cycle, but in this project, a collaborative research project, we're gonna do just a focus on the design. So why is it so? Because the majority of the risk, we're supposed to design out through the process of designing. So it is okay, we are putting our focus on the design. And this diagram shows how fire safety design incorporates fire risk assessment, but at the same time, this shows the scope of our project. So our scope is at is it orange or yellow? The middle one, the putting the focus on the performance-based design supports. So what does this mean from the Canadian perspective? It is, so in Canada, we use prescriptive-based code system. So you may already guess that it has quite a limitations. For example, let's say the innovative building materials and emerging technology, the building technology coming into the building sectors for the sustainability goals and low carbon goals and what else? Energy efficiency and etc. All this, the prescriptive code system cannot provide the design solutions. So what this means is they need to be designed following the performance-based design approach. So you can guess that this project is coming from our long-term strategic goals to, number one, de-risk the new materials and new technology coming into the building sector. And number two, provide some design supporting tools, but not just tools anywhere, but on the digital platform. So what this means is we like to really expedite the uptake of these new technologies. Okay, here it shows the integrated design process of fire risk assessment and fire safety engineering into the building project design process. So it's pretty rather simple. So at the early design stage, when architects doing the planning and the schematic designs coming along, then we carry out initial risk assessments. So given that, we can gauge the level of risk of this new building. And based on that, we provide strategy, so fire safety strategy. So then the package goes, then the design might go to the develop the design stage. Then we're going to get more detailed information about the building. So it's not just coming from the architects, coming from the structural engineer, HVAC engineer. So all the packages coming to us, and we get the essential data and use those data and carry out detailed risk assessment this time, in which we can also use some modeling outputs from the fire simulation, smoke simulation, and evacuation simulation, and etc. Then through our risk assessment results, we can also support the decision making. So which mitigation tool will be the best for the building. So here in this table, I'm putting all the the fire risk assessment tools available at the moment, and on the right hand side of the table, showing the ranking tools. Those are the tools rather simple, so it's probably best to be used at the early design stage, the schematic design stage. And there are many tools available for a little bit complicated risk modeling tools. The FIRA and FireCams are NRC developed tools, and more or less these tools are doing the detection calculations, suppression calculations, and etc. But in essence, what they're supposed to provide you guys is, number one, the impact of the fire on the life and impact of the fire on the property. And some tools capable of providing some business interruption estimations as well. So looking into all these different tools, we figure that these tools, risk assessment tools, require quite a lot of data sets. But when we develop the ideas, the focus should be just the project-specific building design data. So all this data has been listed out, and we just group them together, organize, and showing you in this chart. So let me just figuring out the best way to go through this. Let's say we have a building, one example, and let's say this building is a residential, then we will go to the occupant information. So it's from there, it's a residence building, and how many occupants will be there could be calculated based on the number of units you will build in this building. And then left hand side, maybe the type of construction. Let's say the architect wants to do this mass timber construction type. Then that's the general building information on the left, the column there. And what else? Maybe the designer wants to expose this whole mass timber elements. Then the interior system. Yeah, that will be the exposed mass timber. And then the exterior facade system, you can consider putting the photovoltaic facade system. Then facade system, you have a photovoltaic facade system. And then roof system, you can also again install the roof, maybe some very combustible materials as well. And likely the EV charging and the basement garage systems. So just listening to the description of this building, we can gauge, the level of fire risk of this building. So on the other hand side, we can also have the data, the active fire protection system, for example, sprinkler system, detection systems, and smoke control system. And the passive fire protection system, the design of construction, the thickness of the structural elements, etc., to provide enough hours to protect the building integrity. And then some of the information we would need in the risk assessment is also how far is this building will be located from the nearest fire department as well. So with this, I think in this project, we will develop ideas for fire risk assessment. Thank you.
Thank you, Ian. It's great. And a lot of the data on the screen there is required both for the building performance modeling, where we do the detailed modeling that I showed before, as well as the risk assessment as well, which is why we are running these two IDS tracks side by side, because there's a number of shared data points, both building information, occupant evacuation, etc. So we have a team spread out across the world and a proposed expert panel as well. So the team at the moment is Chan, Asim, Peter and John at the University of Greenwich in the UK, Yoon, Hamed, Hongang, Nuruddin and Farzad in National Research Council of Canada, OFR consultants in the UK, Manuel in Germany, Rui Hang in New South Wales, Australia, myself in University of Canterbury, New Zealand, Timo and Jarno in LAB in Finland, John in Kawi in Norway, Brian at Pathfinder Thunderhead in the US, and also Johannes in New Zealand as well. So spread across many time zones, but we do manage to have meetings together. People have to work early mornings and in the afternoons, but generally most people are used to that nowadays. So, and the expert panel is proposed again, spread across different time zones. Enrico in Sweden, who's a professor at Lund University, Rob Solomon, who is both teaching and also in consulting as well in the US, Wojciech at the university in Poland, and also Peter Senez, Senez Consulting in Canada as well. So trying to get different global perspectives on these things is important when you're looking at those data definitions, because different fire regulations in different countries have different requirements as well. The way we're managing the process is essentially within the general scope and strategy. We're for the most part running with one team, but focusing on these two closely related but different workflows. So both tracks for the fire and smoke modeling and the risk assessment. First of all, look at the process by which design occurs, data gathering, the definition and the calculations, the exact data required, then test that against a model, validate it, run it, and do some analyses and simulations. And ultimately, through that track, we will end up with the data definitions for fire and smoke modeling and fire risk assessment. It's a 2-year project. We have presented at a higher level at buildingSMART Summit before on fire safety engineering overall. The first project was the occupant movement analysis, and that's just about done. And now we're entering this next phase, where we're heading towards 2 IDS files, one for fire and smoke, one for fire risk assessment. And that's broken down further into 3 quite discrete phases. First of all, we will define the workflows in each process track using use cases in the dictionary of the buildingSMART for fire, smoke, and modeling and risk assessments, and establish the full list of all the required data properties. Phase 2, we will then check that data list against the IFC schema. So we'll create a list of the existing versus new properties, aiming towards 2 well-defined use cases, and then ultimately feed that to create 2 draft IDS files. Then the third phase is when we start to add the properties in those defined in the IDS files to some sample models. We test them, we validate them with a number of the range of tools available, log the workflows, enter the use cases into the use case management system with buildingSMART, and also then expand the buildingSMART data dictionary with all the new terms which you've come across. Those 3 phases are mirroring what we did for the occupant movement analysis, and I would say generally is the fairly well-established process now for new IDS-based projects within buildingSMART. And we will have regular team meetings, so whole team meetings probably every 4 weeks, with some IDS-specific breakout meetings, if you like, every 2 weeks to 4 weeks, depending on which phase of the project we are. And ultimately, we're focusing on getting the required data properties, checking out the existing and new ones, IDS files, test and validate, heading towards use case management, with the ultimate game being expanding the buildingSMART data dictionary in these aspects. So in a bit more detail, in the middle with the orange arrow, this shared data aspect of fire, fire source, fire growth, fire definition, feeds into safety engineering or smoke and modeling, and the risk assessment. So working group meetings on a regular basis. From time to time, every 3 months probably, 3 to 4 months, we'll have expert user group or the panel meetings. In this first phase, we will define very clearly the use cases and the process maps for these workflows. We'll come up with detailed lists of all the data points. The basic core data is fire. Then we have the fire development and smoke modeling and the risk assessment built on that. That gets applied to a sample project, and we check the validation with different tools. We used Bonsai to validate the IDS file against the model in occupant movement analysis, and we'll do so again with one of the existing tools. Likewise, we'll be assigning the risk assessment data parameters to some sample models and running some sample calculations as well. And again, reviewing that, looking at the common parameters, testing, discussing, feeding back to buildingSMART with regular meetings, and ultimately aiming towards putting all those new data points into the data dictionary. So last couple of slides, the primary outcomes which we're heading towards, the project deliverables are delivering the use cases, the process maps, the data requirements, IDS files, validation reported on, and project reporting. There's some end user guidance, expanding the data dictionary, some technical guidance, and some example BIM models as well. And those are our core outcomes and deliverables of the project. So we've already done the occupant movement analysis, fire and smoke modeling IDS, and the fire risk assessment IDS are the core deliverables. And lastly, hopefully, the impact of the project. Well, it builds on the occupant movement analysis process and data points, expands the scope of open BIM across multiple domains within fire safety. We will have an open source Revit add-in. Also, this feeds into ISO standards. I'm also on an ISO committee with Nuruddin from NRC, so we'll be feeding some of this work into the ISO standards as well. There's already a technical report drafted. And additionally, all of the work with the fire risk assessment as well complements the performance-based design approaches, guiding transition to performance-based design in Canadian construction. And it also helps develop emerging technologies. And through this richer data set, we can start to have a lot more confidence in modeling buildings with complex data sets. There should be increased productivity through expanding these open BIM workflows. And finally, we will be disseminating through the usual means, through buildingSMART, but also NRC, and also through ISO international standards as well. Okay, that's the end of our talk. Quick shout out to some of our sponsors: OFR Consultants, University of Greenwich, National Research Council Canada, Fire Emergency New Zealand, Brands, Building Innovation Partnership, Fire Research Group, buildingSMART, who are also co-sponsors, GHD Engineering, and also the university as well. So, thank you. Our LinkedIn profiles are on the QR codes if you do want to reach out to us after as well. And that's it from us. I think over to Rob.
Yeah, thank you very much, Peter. Yeah, I think that we're going now online to Sam. Are you there,
Yes.
Sam?
Hello. Hi.
Hi. We need to switch here screens. And
Can
are
we?
you? Okay.
Are we seeing the screen now?
Yeah. And I is here in the room as well.
Yeah.
And I will do the. Okay.
Okay.
Can
So
you hear us and see us? Yeah.
yeah. So hello everyone. I'll just introduce. We're here today to give an update on the buildings domain project, specifically the project focused on the IoT interoperability project. So this is a collaborative effort under the buildingSMART International. Just to give you a brief introduction, my name is Sam Norledge. I'm from buildingSMART UK and Ireland, and I work for a company called LMG. We're a network and design specialist. We're also part of the Lantro Global Alliance partners. So just jump straight into the project. We'll just give a refresh. So we'll talk about why I started the project. In doing my work, design and delivery of smart buildings on site, I noticed a clear disconnect between what clients and stakeholders would request in their structured asset information, but they didn't really care about the IoT data and how it was delivered. All they cared about was that it worked. If you turn a light on, it switches on. As we know, this is sometimes the wrong approach because without data standards, deliverables get washed away into proprietary systems, and you'll get things like vendor lock-in, and that disconnected approach just can't continue. So why is this so critical? So consider this: the 90% of the world's data was generated in the last 2 years alone. So imagine all that data, and then imagine that on the scale of smart buildings and IoT and smart cities. That's a huge amount of data being generated. So the project progress, if you've been following the project, you'll know it's been a collaborative effort between buildingSMART UK and Ireland, buildingSMART Japan, and buildingSMART Singapore. This has been working exceptionally well, and it allows us to share insights and knowledge across continents for smart building enablement and subsequent standards. Along with the buildingSMART collaborations, we're also collaborating with industry partners. This includes universities like University College London, looking at existing research. We're also working with the Digital Building Council on an ROI model, and the REBA plan of works on a smart building overlay. And of course, we're layering existing ontologies and naming standards like the brick schema, Project Haystack, and the digital buildings ontology. All of these collaborations have resulted in weekly workshops and numerous articles explaining the disconnect and gathering industry experts. So gathering these experts, and reviewing all the existing research, we found some of the following. So first is the brick schema, which has been a fundamental part of the project from day one. Early workshops with the schema's creator highlighted some of the fundamental issues with defining control relationships within IFC. We noted that Open 223, which is an ASHRAE standard, does this a little bit better than IFC, and we can learn a lot from Open 223. Project Haystack. This was a much easier schema to map to IFC, as it's just a simplified tagging on methodology for control points. So different controls just had different names. Previous efforts have been made to map these, and we plan to utilize some of these works for the new buildingSMART Data Dictionary entry. And then we've got the BDNS, which we'll cover in this presentation. So this showed obvious untapped potential, into adding it into the data dictionary, but we'll cover this later. And then fourth is the UDMI. This also presents a lot of opportunities to be enabled by IFC for its delivery. So I've covered these two. Yeah, I know they're not defined, but I'm hoping we can go through this now. So BDNS, the Building Device Naming Standards. So simply put, it's a naming syntax for asset naming. For example, an air handling unit in a building uses the abbreviation AHU. It's a long list of these types of abbreviations and a standardized numbering and QR codes and their specific payloads that refer back to GUIDs in an IFC model. This is a widely adopted naming standard in the UK, and we can see a huge opportunity to adopt the BDNS into buildingSMART data dictionaries. So next we'll touch on UDMI, the Universal Device Management Interface. But before we go into that, I need to explain, need to discuss quickly what MQTT is. So MQTT is a cloud-based hub and spoke model. It's a publish and subscribe messaging protocol designed for low bandwidth, unreliable networks, or instances where huge amounts of data is being transferred. It's adopted across industry from manufacturing to shipping. And in our case, it's used for building controls and control of IoT. UDMI is basically the standard format for MQTT payloads. It's an open source framework that standardizes how IoT devices are managed. It acts as a common language, ensuring communication between different systems can happen via a machine. We like to think of it as like a HTML for the built environment, which it's a fully interconnected ecosystem. So we're just going to break down UDMI payload. So first, we have this telemetry data. This is your point data, like a temperature set point on a temperature gauge in a room. If someone moves it to 19 degrees, that payload gets sent in this format. UDMI does this quite well, this telemetry information. That's kind of what it's designed for. And we don't see a use case at the moment for implementing these sort of control relationships in IFC. Second is the asset information. So this is where we can start to draw the links to the IFC. We could use GUIDs to map this data and take the asset names from the BDNS. There's potential here for IFC to aid the process of delivering this part of UDMI. And then third, we've got the locational data. Obviously, we can draw a lot of links to IFC here. We can bring across a lot from the XYZ coordinates and room numbers, names, and the coordinates. And then finally, we got the metadata. So the relationship part of UDMI. Our research will further explore how we deliver this section, as currently it's difficult to implement on scale, and we'd like IFC to help enable it so it's not so difficult to build. And at this stage, most of these UDMI payloads on day-to-day are being built manually. It's important that this importantly gives us like ample opportunities here to present IFC as a delivery aid for these guys that are delivering this UDMI. And now I'm going to hand over to AI Yamamoto, who's going to take you through an overview of the project challenges and findings so far.
Thank you, Sam. Hi. Hello, everyone. Let me introduce myself briefly. I'm not AI, I'm from buildingSMART Japan chapter. And I'm also working as a research engineer for Kajima, which is one of front runners for construction industry in Japan. Sam was talking about the objectives of our project and several standards that we need to align with in order to integrate building assets with IoT for smart control. So from my side, I briefly outline a couple of specific approaches to leverage buildingSMART standard and service to enable IoT interoperability. Next, please. Currently, several metadata schemas that represent building information have existed. This figure created by IEA shows the characteristics of each metadata schema and their main application domains. On the right side, we have our IFC, which is our strict and complex schema. And it's not very web-friendly at this moment. That's why IFC is considered to be more suitable for asset management systems during operational phase. In the middle, we have other schemas such as brick or real estate core, which are designed to be support point telemetry data and to be web-oriented. So for these reasons, they are seen as more useful option for area of smart buildings interconnected with technology like sensors, IoT devices. I mean, use of IFC in the building, use of IFC in smart buildings is limited. Smart buildings require more agile data format and a more appropriate metadata schema than IFC. Next, please. But BIM and IFC still have the advantage of structural representation for building components and systems, and play a critical role in delivering building information, especially for design to construction to and handover. So we think IFC is useful to generate our metadata model for smart building by converting an IFC file to other schemas. However, there are some challenges in converting IFC file. Next, please. One of challenges is the difference in the level of details or granularity among ontologies. When converting to brick from IFC, its applicability is not so high. For example, brick has various classes for fan, including ceiling fan, but IFC does not have such detailed class. For IFC 2x3, the gap is even bigger than IC 4.3. So therefore, we to enable automatic conversion, we have to identify what type or what class in brick each IFC type, each IFC component should be converted to in advance. And other challenges come up in modeling process. Asset names and identification are not frequently matched among different sources, different phases, because of the lack of a naming and standard naming convention throughout entire building life cycle in most countries like Japan. And in addition, there are many objects whose type of IFC is not set in modeling. So therefore, it is difficult to identify what type of device it is based on IFC type. Next, please. So we on our project are trying to map IFC class and IFC type to other ontology, collaborating the BDNS working group, as Sam mentioned earlier. This is mapping table. On the right, left columns list the BDNS asset description and asset abbreviation, and in the middle we have IC class and IC type, and the right side you find brick and other ontologies. We're gonna enrich this table to clarify the relationship between ontologies. Next, please. Once we build the matching table, we'll upload it on BSDD. buildingSMART said the one of use case of BSDD to add external classification and properties, as you can see this figure. And so it seems better or easier to add specific usage classification for like smart building with BSDD to IFC. Next, please. So this is here is a sample of using BSDD. It shows the device name and abbreviation from BDNS, and at the bottom you find the other related ontology class listings, including IFC type and other classes. We believe the core of mapping will be BDNS names, because the names, asset names from BDNS are designed not only to be used for BIM, but also to be sufficiently detailed to allow automatic acquisition of data from devices in operation. So the granularity of BDNS is suitable for our scope. Next, please. This shows the process to add other ontology information. If mapping information is set on BSDD, BIM modelers can refer to it as reference, and then based on IC type or asset names, they can choose and extend relevant information for other ontology accurately based by plugin or other IFC viewer. So we can use BSDD as some kind of platform of ontologies. Next, please. There are already some solutions and tools to support BSDD. So we believe BSDD will contribute to enable IoT interoperability. that's enough from me. I hand over to Sam.
Thank you, Sam. So next steps on the project. So hopefully this gives you a good insight on the projects. So next steps would be the BSDD update. So we would like to submit the BDNS definitions for review onto the BDNF, onto the BSDD. These acronyms are pretty difficult. These two, BDNS and BSDD, it's they're difficult to work alongside each other, but we'll work with that. So the IFC schema recommendations. So we're going to report our findings on brick and haystack and some of those challenges that ISAN was going through. So we would report that back in a white paper. And then we want to commit. We also want to be improving other systems and other schemas out there. So we are going to commit some of our changes onto the Building Device Naming Standards GitHub, so they can benefit from some of this work as well. And then we've also got the haystack mapping to do alongside what ISAN was going through. I think we could potentially add more onto that, and potentially we could even add a BSDD entry for Project Haystack. Now, if we look back at the project aims, the original project aims that we put in for the project proposal, so we've completed some of the actions. So we are suggesting the improvements onto the GitHubs, other projects' GitHubs. We are using standard naming principles from the industry. We're about to review the issues and suggest improvements to the IFC schema via a white paper, and mapping the ontologies to IFC4. That's what we're currently doing now. And then finally, we want to deliver this methodology on a live IoT architecture once we've completed all the works. So that will be coming. So I think that's it. So thank you very much, guys. Really appreciate the opportunity to present to you today. Thank you.
Thank you very much. So, yeah, we have some time for questions. If there are questions, I have a microphone. I can walk up to you. You have a question?
Yeah, Michel Burms, TNO, colleague of Rob. I have about 100 questions, but I have to make a selection of two. I really like the BSDD-based approach, because then you stay into the system in a sense. But I was also wondering, how would you deal with the actual payload data itself? Not the metadata from the sensor or the equipment, but the data itself. Will it be external JSON, or will it be also some way using IFC time series, or that kind of stuff? That's my first question. And the other question is, this morning we had in the product room a similar proposal for IoT data, metadata and payload data from asset administration shell, from the Industry Digital Twin Association. Also IEC standard as an alternative column, you could almost say, next to all the other acronyms as a potential way forward. Did you consider it, or is it compatible, or maybe it's something new?
Is that a question for Sam or I to answer? Sam, I is directing to you.
Yeah, sorry, I was just trying to find the mute button. Yeah, that's a great question, actually. Thank you for asking that. So the first question was about the format. Yes, so UDMI is a JSON payload at the moment, so we would look to continue that and use JSON as the main format for that file. And then you mentioned about Industry digital twin. I've not come across them before, but I'd like to hear more about that. But we are collaborating with many different industry movements, like the Digital Building Council is part of that, and we're getting a lot of experts, a lot from the building controls industry. Because this is primarily building controls at the end of the day, but we're trying to assist these building controls engineers with some of the knowledge that we've gained from all these years of standardization within the BIM and IFC industry, and what buildingSMART have done previously, we can bring into the building controls industry, which is the main goal of what we're trying to do here. Does that answer your question? It's a bit wishy-washy there.
I see that. Oh, okay. Well, Christian from Siemens has a question as well for you.
Yeah, thank you both for this great demonstration. This is exactly what we need in order to make the operation better in the building life cycle to support this. Maybe you heard about this agreement from buildingSMART International with the IDTA, Industrial Digital Twin Association, which was announced last October. And exactly based on this agreement, we established a project group on how can we bring the asset administration shell, which is actually a vendor-neutral format of the asset data. How can we bring this together with the IFC, with a billing model, in order for operation to locate the asset and also to retrieve live data from this asset? We had this demonstration this morning from Vienna Airport. They proved it in a project, so how it works. The main idea, or the fundamental idea, comes out of the industry, from the shop floor machine communication, where the customer said, well, I don't want to implement 15 APIs from 15 vendors in order to do my control of my shop floor. And we have the same situation, I mean, even worse, in the building automation. So that's why we said this makes really sense to bring this technology also to the building sector, to make the operation more efficient, more vendor independent. Also, we deliver our products to the building industry, but also ABB, Schneider, and you name them. They have the same products in the building. And we access the data, let's say a temperature, from a temperature sensor at the same place, no matter who delivered this product. And the asset administration shell is actually the link between the real world and the digital world. And the server for this asset administration shell has an API where you can retrieve this information very simple, let's say this way. As I said, this morning we had the demonstration. We do much more. We can directly connect to Modbus or BACnet or whatever to read out, also for existing systems, to read out the data in the same format. So I think it would really would make sense in order to cooperate here with what you do, to see what we can, how we can strengthen, let's say, the operational phase, because this is where the facility management, everybody struggles. But I also agree that we need to have reliable IFC data for the building. Otherwise, we have grab in, how do you say, grab in, grab out. So it is important. So that's why I really appreciate your initiative. And unfortunately, I wasn't aware of it in that, because I don't know, communication isn't working within buildingSMART. That's another issue. Like you didn't hear from the IDTA agreement. I didn't hear about your project, because this would be really something where we could work together. So thanks a lot.
It would be beneficial. There's a lot we can learn from industry IoT as well, and it's not something we've been focused on as a project, because we're the buildings domain and we are just focused on buildings at the moment. But there is a lot we can learn from industries, and I think a coming together would be really, really necessary in this project. Thank you for your question.
Let's
Really
stay in touch.
Yeah, that's a good takeaway. Thank you very much. Well, is there anybody else with a question? Maybe perhaps about the fire safety ideas, developments? No?
There are a few questions online.
Oh, are they? Yeah. Okay. Fantastic.
This is the first question.
Shall I read it out?
Yeah.
Okay. How to export metadata when we convert native BIM to IFC format? Is that a clear question to you? How to export metadata?
The metadata wouldn't come directly out of the BIM file itself. This is some of the challenges that ISON has presented, that some of the metadata isn't that easily mapped to IFC, because what we're talking about is point data. So a temperature set point in a room, or a fan control speed, that sort of stuff is never going to really come out of IFC. And really, is there really a use case for it? And this is what I was trying to present earlier, is yes, we've got that asset information. We've got a lot of static information in IFC that we could utilize. Some of that point data and the relationships, we can build on that, but it's not really necessarily a focus of the project right now. That answers the question.
Well, I is nodding her head as well, so I think this answers the question. Are there more, Laura? Would you also recommend the use of universal, unique, and interoperable core maintainable asset identifiers like GS1, serialized GT, and more abbreviations? In this way, the golden thread of product knowledge capture and communication continues post-installation as well. So would you recommend the use of a universal, unique, and interoperable core maintainable asset identifier? Is that a new development then?
GS1 is it's like barcoding, isn't it? Yeah. We are collaborating with GS1 as well on some of this. So if you saw in the previous slides, the BDNS actually has a specific payload format for a QR code, and that's for asset tagging. And this has been for the Building Device Naming Standard Initiative has been thinking about that, and they are currently collaborating with GS1. So yeah, definitely part of what we're
And I'm
doing.
almost certain that, Christian, you are working with barcodes on your... do you want to maybe respond on this as well?
Yeah, for the industry, they will use a digital matrix code, which is also a unique identifier, and that is hosted by the IDTA. It's similar to what GS1 is doing, but the data stays with with the provider. So we have a single source of truth, which is mainly coming out of eClass when we for our products when we fill up the asset administration shell, and this link is done via the identification of the product is done via this digital matrix code, which is part of the AAS. And actually, this code will also be used in order for the digital product passport, which is necessary in future by regulation in the EU at least. And I also think there is a high demand from customers to digitally access their documentation and all this stuff. And for this, we have another submodel for documentation, certification, and all this stuff within the asset administration shell. It's part of the concept, but the identifier is this digital matrix code, which is also described submodel and standardized.
Well, thank you for responding to this. So I think there's a lot of going on as well already on the unique identifier topic. Are there more, Laura? No, there are not more. Are there more from the audience? Yeah, Michel? On the first topic, of course. Yeah, sure.
Thank you. You showed you made two IDSs. I assume it's over IFC, some version, plus some fire dictionary or reference fire dictionary. A question about this dictionary. Did you actually use the Excel front end? Is that available for generating the BSDD content? Or how did you develop actually the dictionary, the fire dictionary, of how it's called?
I mean, when the occupant movement analysis, is this working?
Yeah.
In the occupant movement analysis project, we just generated it on a spreadsheet, ready to export. My expectation is we would probably do the same here, just generate a spreadsheet ready to export for the BSDD as well, just for transparency. I think that's probably the process we would go through. That's my expectation. Yeah, and two spreadsheets, one for fire risk assessment, one for the fire and smoke modeling. Yeah.
There's another question from the back of the room. There you go. Can you introduce yourself?
My name is Kyung from South Korea. The buildingSMART Korea. For the fire safety, I have a question for the new innovative building design implementation in the fire safety. For example, if you have a modular building, actually that is not typical. So somehow the building element should be adapted in the IFC perspective. But then also if you added the kind of the methodology, so for the modular building into the fire safety, the modeling, actually you might need to have the fire solution to be implemented together, somehow combine the IFCR model and then fire safety itself, some other simulation. So do you guys think about how to apply sort of the different simulations, the incorporation into the IFC? Have you thought about that for the kind of new technologies, innovative building technologies?
Do you want to go first?
I don't have a very good answer to that question, but I think it's something that we need to think of in advance, because it's regarded as a one product, right? So it needs to be treated properly. I don't have answers to that, but maybe you have.
Yeah. So my expectation is that in the construction definition in the IFC file, there for the most part should be sufficient level of flexibility in the material layer definitions to be able to define those panels. You would have to develop the geometry of the modules and also ensure that all of the materials in the different layers of the construction were well defined and oriented in the right way as well. The only extra thing is if you've got some new material, like a phase change material or something for particularly high-end stuff, you may need to expand the dictionary at that point. For the most part, there's a pretty wide spread of definitions in the material database, but it is possible, like a phase change material or something like that might require the data definition to be expanded. I mean, we're doing the next phase over the next 2 years, but my expectation is that there will be further phases in the future as new materials come on track as well. Yeah.
Okay, thank you very much. So before we give the speakers a warm applause, I think that Laura has some final remarks, or no? No closing words? Okay, well, no, I assumed it, but thank you very much. And I appreciate your being with us, and please accept our applause.